Assalamu alaikum. This is chemistry 11th, and our today's lecture is about and merits and demerits of this Mendeleevs periodic table. As I have already told you about this Mendeleevs periodic table, that this periodic table is based on atomic mass, and the elements we see that they are arranged in increasing order of their atomic masses, with similar atoms getting repeated after regular intervals. Now, as far as although Mendeleev, he did a very commendable job in this. In this field, in classification of these elements. So this periodic table has got merits as well as demerits, as well as demerits. Now, as far as the merits of a Mendeleev's periodic table, or Mendeleev's periodic table merits are concerned, we have got the first merit, that is systematic study of elements. It has made easy the study of elements and their properties, because by knowing the properties of one element in a group, the properties of other elements in the same group can be predicted. So since we have got more than 100 elements, but at that time only 60 elements were known. Now, instead of studying the properties of all these elements separately, we need to study the properties of 9 groups only. Because in Mendeleev's periodic table there were 9 groups, so this has made easy the study of elements and their chemical properties. Now, the second merit of a Mendeleev's periodic table is prediction of new elements and their properties. Now, in Mendeleev's periodic table, we have seen that elements are arranged in increasing order of the atomic masses, and more stress it was laid on the similarity in properties. And I will again repeat it, that the elements are arranged in increasing order of their atomic masses, and the stress it was laid on the similarity in properties. So whenever a particular element did not fit in this arrangement, or in his periodic table, in Mendeleev's periodic table, he left a gap in his periodic table, because some elements were not known at that time. Mendeleev, he predicted the presence of elements in such gaps, and even predicted their properties in advance, which were later on found to be correct. So a Mendeleev's periodic table was very helpful, or it was of great help. It helped to a greater extent in the discovery of the new elements, like we have got this Eka silicon, and we have got Eka boron, Eka aluminum, and this silicon. Now, then we have got another merit of this another this merit of this, advantage of this Mendeleev's periodic table, is that is correction of doubtful atomic masses. Now, as Mendeleev's periodic table, it was also of a great help. It helped to a greater extent, and in the correction of atomic masses of certain elements, with the help of their expected positions and their properties. For example, one of the elements, that is beryllium. Beryllium, it had been assigned an atomic mass of 13.5 at that time. It was assigned an atomic mass of 13.5 by multiplying its equivalent with its valency, which was assigned at that time 3. This was wrongly assigned a valency of 3. So by multiplying its equivalent with its valency, its atomic weight or atomic mass, it came out at 13.5. So therefore it should have been placed between carbon, which has got atomic mass of 12, and nitrogen, which has got atomic mass of 14. But as far as the properties of beryllium are concerned, concerned, it suggested that it should be placed in second A group of the periodic table, with elements magnesium and calcium. So it was assigned a correct valency of 2, and its atomic mass was assigned 9. So this is how this periodic table helped in the correction of these doubtful atomic masses, and I have given you the example of beryllium. Now, in a similar way, atomic masses of many other elements were corrected. Now, these are the merits. Now, as far as demerits of or the defects of Mendeleev's periodic table are concerned, although we see the periodic table was quite helpful in arranging a large number of elements into groups and periods, but this periodic table suffered certain defects and anomalies, and one of the anomalies is that is this I would like to tell you, that is position of hydrogen. Now, as you know that dear students, that hydrogen has been placed in first A of the periodic table with its because with its resemblance with these alkali metals, that is lithium, sodium, potassium, etc. But it also resembles the group 7th A of the periodic table, which are that group is halogens in many of its properties. So its position in periodic table is controversial because it results halogens in some of its properties, and it also resembles alkali metals in some of its properties. So its position of the hydrogen is, it is controversial. Now, as far as the second defect of this Mendeleev's periodic table is concerned, we have got this anomalous position of some elements. Now, as the elements are arranged in increasing order of their atomic masses in Mendeleev's periodic table, but it has been found that in some cases the elements with high atomic mass it was placed before the element with low atomic mass. For example, argon. Its atomic mass is 39.9. It was placed before potassium, which has got an atomic mass of 39.1. Similarly, we have got another element, cobalt, which has got atomic mass of this. Which has got this cobalt has got atomic mass of 58.9, and it was placed before this nickel, which has got atomic mass of 58.7. So this was the it was the anomalous position of these elements, that is the element with higher atomic mass, it came first, and it was followed by the element with low atomic mass. So this is against what Mendeleev said, that while placing the elements in increasing order of their atomic masses. So Mendeleev, he could not give any justification for such anomalous such anomalous positions. Then we have got the position of isotopes. Now, as far as isotopes are concerned, these are the atoms of the same element which have got same atomic number, but they have got different atomic masses. Now, as the periodic table was based, Mendeleev's periodic table was based on increasing order of atomic masses. So there should have been different positions for isotopes of a particular element. For example, in case of hydrogen, we have got three isotopes. We have got protium, deuterium, and tritium, which have got respectively their masses 1, 2, 1, 2, and 3 respectively. So there should have been three positions given to these three isotopes of hydrogen, but actually but they have been given only one position. Since so this is against Mendeleev's Mendeleev's law, that is the periodic table was based on increasing order of the atomic masses. Now, then you have got this another is, that is the position of lanthanides. As we know, they lanthanides and actinides, these are the two series which consist of 14 elements each. Now, as far as Mendeleev's periodic table is concerned, there is no position. There is no position in the mean periodic table in case of Mendeleev's periodic table given to these two series, that is lanthanides and actinides, and they have been placed separately in two rows at the bottom of the periodic table without giving any proper reason. Then we have got this is the position of the lanthanides. Then we have got one more defect, that is no correlation of elements in subgroups. No, since in Mendeleev's periodic table we see that each group was divided, that especially from 1 to 7, they were divided into subgroups A and B. Subgroup A and subgroup B. Subgroup B. The elements in a particular group, we know that according to Mendeleev, the elements in a particular group, they resemble in their properties, but there is no similarity among the elements of two subgroups of a particular group. For example, we see that. We see sodium and lithium, sodium and potassium, which are present in first A group of the first group. They are quite different from copper, silver, and gold, which belong to the first B of the same group. So there is no similarity between these elements. So this is another defector, that is no correlation of elements in subgroups, that's A and B. Then we have got the cause of periodicity. Now Mendeleev, he could not provide any this satisfactory explanation, or he could not provide proper explanation for the fact that why elements in a particular group show similarity in their properties. So these are the merits and demerits of this Mendeleev's periodic table, and this is for today. And in our next lecture, we will discuss this. We'll take this long form of periodic table, or modern for modern this periodic table. This is for today. Thank you very much.